Hi everyone, I'm Zdenek, CTO at Codasip, and today I'd like to show you the profiler, which is one of our tools that is generated from the processor description. What you can see on the screen at the moment is just a benchmark. In this case, we are looking at the bit reverse benchmark. Why bit reverse? Well, bit reverse can be found in many DSP applications, so we've chosen this benchmark to showcase the capabilities of a profiler and how profiler can help you with the instructions and extension for your CPU. If you look at the code over here, just a bunch of lines in C, what we can do with that is we can use the vanilla RISC-V that comes with the studio, and we can see where we stand on the day one. If we do it, which I already did, the profiling report is generated and it has two forms. It can be either HTML output or it can be inlined into the editor. I will showcase the inline version. So if I do it, if I show the results of the vanilla profiling run, we can see that the most of the time is spent in the main loop, which is the benchmark loop. And we can see some information about the C lines, and if I move a mouse pointer, I can also see the assembly of the functions. I can see where exactly the time is spent. Now this is, let's say, the standard profiling. You can find it in the other environments as well, but what we have on top of that is that when you do some customizations, you can compare visually with the original result. In this case, since it's a bit reverse benchmark, what we did is that we added bit reverse instruction to our RISC-V processor. The instruction itself is quite easy to follow. If I open the file, we can see that we have a new instruction using our language. We have the bit reverse in the assembly, just two operands, one input, one output, binary as given by the RISC-V specification, and more importantly, we have the body of the instruction itself. We are reading one operand, we are computing the results, and we are writing back. Now the results is computed in the extended module that is prepared there, and if you look inside of the module, it's quite simple. In this case, we are using one of the library that comes with the studio that has implemented quite a few DSP operations already for you, for your convenience, so you don't have to write them manually from scratch. In this case, we are using bit reverse built-in. If we do that, and if you run the profiling again, which I'm going to do right now, so let's run the profiling. It's quite easy. We need to firstly build the project. I have the release mode. Let's build it. I have a project is ready, is being built, and now I can run the profiling, which I'm using the cycle accurate profiling to get as precise results as possible. Now the profiling is done. I can see the outcome, and in this case, I'm interested in the fact that I like to see two next to each other. And in this case, I can do it like this. I can just send append report to the second column, and if I make it a bit bigger, then we can see that in the first run, the majority of the time is spent in the bit reverse itself, while in the second run, we can see that it's highly optimized because of the new instruction that has been used by compiler automatically. So you can then compare the results. You can really easily see whether the hotspots has been fixed, and if so, how. So this is a profiler that comes with the Codasip Studio. Thank you for your attention.